Good morning, everyone. My talk today is mainly to provide you an introduction to the Commonwealth Environmental Water Office's long-term intervention monitoring project for the environmental flow delivery to the Lower River Murray. And I'll provide some initial findings and research outcomes from 2014-15. So CHIO's long-term intervention monitoring project is a 5 years project, and it's conducted by a research consortium in the Lower River Murray led by SARDI, but involved many collaborative researchers such as CSIRO, Adelaide Uni, University of Western Australia, and Wetland Research and Management. And the program is having strong support by DUNA and MDBA, as well as EPA in South Australia. And I should acknowledge my co-authors, as you see a long list and big project team, and particularly the task leaders, such as Ken Aldridge, Matt Gibbs, Rob Oliver, Russell Shield, and Brenton Zampatti. They are leading the ecological components of this large 5-year project. So river regulation and flow modification have a severe impact worldwide on the riverine ecosystem. Environmental water have been used to try to establish some ecologically important flow components, such as the magnitude, duration, increase and reduce rate, and basically to restore the ecological processes and rehabilitate the key biotas. So over the last quite few years, Commonwealth environmental water holder have delivered significant environmental flows to South Australia. And for example, in 2014-15, about 581 gigalitre of Commonwealth environmental water was delivered to South Australia. So CHIO's long-term intervention monitoring program, we call it LTIM, was established in 2014, and with the general aims to conduct monitoring and evaluation for the Commonwealth environmental watering, basically to demonstrate the ecological outcomes, but also to help support adaptive management. And the monitoring and evaluation plan was developed in 2014 with this consortium research team for the Lower River Murray selected area. And the project is actually concurrent. There are 7 selected areas across the basin for the LTIM program. And that's the website if you want to see the detailed plans for the 5 years program. So to put the flow delivery in context of the channel morphology, in the Lower River Murray, base flow normally sort of equivalent to our entitlement flow between 3,000 and 7,000 megalitre per day. And when you get to bankfull flow, roughly in South Australian part of the Lower Murray, is between 40 to 50,000 megalitre per day. And considering the constraints of flow delivery and the environmental water use over the life of the evaluation period, 5 years, I think the CHIO indicated that environmental flow will result in flow delivery not more than 60,000 megalitre per day in the Lower River Murray. So most of the e-flows will contribute to this in-channel flow, they call it freshes. Therefore, a series of ecological indicators, environmental indicators, were established for the Lower River Murray, and mainly for between the border and Wellington, and focus on the main channel response. So we call it Category 1 and Category 3 indicators. So basically, Category 1 is mainly designed for the basin evaluation with standardized method established across the 7 selected areas. But specific Category 3 indicators were designed for the Lower River Murray by my project team, is to specifically conduct evaluations regarding the response to Commonwealth environmental watering for certain aspects of the ecology in this region. And I should highlight that stream metabolism, actually, that all these category 1 indicators will provide data to the QO and MDFRC to conduct basin-wide evaluation. But stream metabolism actually serves both needs for the basin-wide and our selected area evaluation. And hydrology data actually provide a fundamental information for the evaluation of environmental flow contribution to ecological response. So typical evaluation questions look like, what did CHU contribute to? So for example, specific things we evaluate is, what did you contribute to hydraulic diversity in the whale pools along the River Murray? And what did that contribute to salt, nutrient, and phytoplankton transport and export and concentration? And what did you contribute to abundance and diversity of microinvertebrate? And we also have this indicator using that flow queue spawning species, which is golden perch, to basically assess about what did the delivery of Commonwealth environmental water help with the spawning and recruitment of golden perch. And for stream metabolism, we ask, what did you contribute to pattern and rates of primary productivity and decomposition and the dissolved oxygen in the lower River Murray? So these are just a few examples about evaluation questions. So general approach, for hydrological regime, basically that we conduct hydrodynamic modeling, not we, Matt Gibbs, basically to look at the velocity change, so which change the hydrodynamics in the river channel. It is very important for the ecological process and biota about how the hydrodynamic works, and also how that affects the water level in the whale pools. And matter transport is conducted by Ken Aldrich. Basically, it's using a model called two-flow FV. So it's a coupling of hydrodynamic and biogeochemical model to basically assess about salinity, salt, nutrient, phytoplankton transport, export. So both components is using a modeling approach, which will allow the scenario analysis, they call counterfactual analysis of hypothetically with or without truth. So you can estimate about what's the environmental water basically contribute to that, those kind of ecological outcomes in a quantitative manner. And this is just an example from that Matt's modeling is showing that actually both modeling, we have some data to validate the model. And this one is about the velocity between log 3 and 4 in that whale pool at the lower, middle, and upper whale pool. And generally showing that it's quite good alliance between the model output and also on-ground field investigation from whale pool manipulation project by Chris Bice, I think. And about the shapes, why that look like wine glasses and beakers, I don't know. You can ask Matt Gibbs. So another general approach that the indicator of stream metabolism, microinvertebrate, and golden perch spawning recruitment will involve a lot of field investigation. So such as the in situ logging, data logging for DOs, temperature, and also the incidental radiance for stream metabolism. Also collect water samples and send to AWQC for analysis. That's done by Rod Oliver's group. And also we collect microinvertebrate through trapping and littoral sampling and sorting ID done by Russell Shields. And also that golden perch spawning recruitment involve larval sampling, basically conduct larval sampling between spring and early summer as an indicator of spawning success. and then follow up in autumn with electrical fishing to collect juvenile fish to see that whether they survive to young of the year, so as a recruitment success. And then we also take out the year bones, which is otolith. It allows the daily and annual aging to look at how old these fish is, so you can back calculate the spawning date. And so these are led by Brentons and Patty. And you also look at otolith cores and look at otolith microchemistry, so strontium isotope, which can help you to identify roughly where this fish is spawned. So you know where and when, so you can relate to flow delivery pattern and environmental watering. So these just show the main channel of the lower River Murray and lakes and Coorong. As I said, most of the indicators were within the main channel between Wellington and the border, but the meta transport modeling actually extended to the lower lakes and Coorong and Murray Mouth. So, and just to show you that, so for the field data collection, mostly is concentrated at below Lock 6 area as representative of floodplain region, geomorphic zone, and then also that below Lock 1 area as a representative for the gorge section. But the modeling component is for the whole river channel. Oh, I should say that Category 1 fish assemblage electrical fishing actually is between Lock 1 and Lock 3 to collect the data. So quickly highlight a few outcomes. So with that 581 gigaliter of chew delivery in the lower Murray, the flow maintained at 9,000 to 10,000 megaliter per day during spring and summer, and also supplement the continued barrage release and top up lower lake water level from September to June. And we also found increased hydraulic diversity with increased median velocity up to 0.07 megaliter per day. And so some cross sections actually increase from the slow flowing habitat to moderate flowing habitat. And also that we found increased water levels. For stream metabolism, we found intermittent increase in carbon supply to the river might be associated with the Chila floodplain inundation using the living Murray water, but supported by the main channel release of chew. A little bit DO drop, but it's not lethal. So about meta transport, we found increased transport of nutrient phytoplankton and increased salt export from the lower Murray and lower lakes, and reduced import of salt to the Coorong, and reduced concentration of salinity in the Murray Mouth. We also found increased microinvertebrate abundance and species richness, probably associated again with the improved lateral connectivity between main channel and Chila. Okay. Unfortunately, we didn't find much fish spawning and recruitment, which only 9 larvae found and 1 juvenile fish found. So this is not surprising because usually the fish spawning, actually golden perch spawning success occur associated with in-channel flow variability and overbank flows, or the massive pulse from the darling. So the moderation of flow from that Houston flow that will disappear at the SA border might lead to the reduction of these spawning success for golden perch. So just to let you know, the report is being published in that, on the website, on GEO's website for 14-15. A detailed management recommendation was provided for each indicators, but the general message is that flow is important for hydraulic diversity and delivering flow connectivity, source of flow, maintaining the flow integrity. It's extremely important to maintain the ecosystem health in the lower River Murray.
Sorry, I have to stop
Thank
you
you.
there.
All right.
Sorry, we've almost again run out of time for questions, so I'll hand over to Jennifer Shaw